The role of meltwater. The nature and rate of processes converting snow to glacier ice change with the climatic environment. They are more varied and proceed at more rapid rates under warmer conditions. The development of meltwater, especially in copious amounts, is especially significant with respect to both densification and thermal relations. Meltwater develops at the surface and percolates down into the underlying permeable material, where it refreezes as long as that material is at temperatures below 0 degrees Celsius. A certain amount of dispersed percolation must occur, but in addition, a lot of the percolating water is channeled into essentially vertical cylindrical pipes. These pipes extend downward 5 to 10 feet from the surface. Meltwater spreads out laterally from these pipes, along pervious strata, or on top of impervious layers in the snow or fern, where it refreezes to form ice lenses and layers. This is one of the ways by which the original stratification is accentuated. The cause of channelization into the pipes is not clear. It may involve irregularities on the snow surface or internal inhomogeneities within the snow. Once started, a pipe seems to be self-enforcing phenomena which grows and maintains itself as long as the supply of meltwater continues. Eventually, perhaps because of a change in the weather, the water supply is cut off. When this happens, the percolated water quickly refreezes by loss of heat to the surrounding cold fern and snow. This forms a crude vertical column of ice within the snow with horizontally projecting ice layers and lenses. Features of this type have been observed in the snow and fern of a number of glaciers, and the process has actually been witnessed in action near the edge of the Greenland ice sheet by Carl Benson. The percolation and refreezing process goes on principally during spring and early summer, when significant melting first occurs and when the underlying material still contains the winter's chill. An annual snow or fern layer may be exposed to several cycles of meltwater percolation and freezing before it becomes too deeply buried to be affected by seasonal temperature variations. The conversion of snow to solid ice proceeds much less rapidly in cold areas devoid of meltwater. Here, grain deformation, vapor transfer, and possibly local pressure melting must play a relatively larger role. Have a great day.